NASA's spacecraft have not yet encountered the three outer planets in the solar system, Uranus, Neptune, and Pluto. Yet these planets are not totally unknown to us. In recent years, new knowledge has been gained about them. I'm your host, Larry Ross, Director of Space Programs at NASA's Lewis Research Center in Cleveland, Ohio. This is our last program in our Journey Through the Solar System series. In this program, we will examine the three outer planets and will learn about spacecraft messages to other life in the universe. And we will also look at comets, meteoroids, and asteroids. There is a zone between Mars and Jupiter known as the asteroid belt. Here there are thousands of asteroids, many irregular in shape, orbiting the Sun. Most of these small planets vary from as small as a boulder to as large as a mountain. Some are larger. Ceres is about 600 miles across. Astronomers think that the Martian moon Phobos may be a captured asteroid. By examining its photograph closely, scientists may be able to learn more about asteroids. On a dark night, it is not difficult to see a shooting star, a meteor. A meteoroid is a chunk of rock or metal orbiting the Sun. Meteoroids may come from the asteroid belt or at one time may have been part of a comet. When meteoroids enter the Earth's atmosphere, they often burn as a result of friction between them and the Earth's atmosphere. Those objects which survive the fiery path to the surface of Earth are called meteorites. Sometimes they form craters on impact. Other times they fall harmlessly to the ground. Now let's see a short NASA 1980 videotape release about the search for meteorites in Antarctica.
These visitors from outer space come in a variety of shapes, sizes, and colors. They are meteorites, some 4.5 billion years old. And they are being found in relatively large numbers in Antarctica. 1,300 have been collected during the last few years. The total number of meteorites in collections around the world was only 2,000 before the Antarctica finds. So the discoveries there have come as a tremendous surprise to scientists interested in doing research on these cosmic travelers. The meteorites are really small fragments from an asteroid belt that might have helped form a planet. Many of them are drawn into the orbits of Jupiter, Mars, or even the Earth. So here in Antarctica, preserved by its icy conditions, is some of the oldest material of the solar system. Some of the very material that went to make up Earth, for example. By studying meteorites, scientists hope to find answers to two very fundamental questions. Is there life beyond Earth? And what are the processes that led to life on Earth? NASA and the National Science Foundation have been working together to preserve the meteorites for careful analysis. At the Johnson Space Center's Lunar Receiving Laboratory, the meteorites are prepared for distribution to scientists all over the world. They are handled similar to the way samples returned from the moon by the astronauts are handled. One of the people analyzing the meteorites is Dr. Cyril Panemperuma, director of the University of Maryland's Laboratory of Chemical Evolution.
So what we are trying to find out in the meteorites is to see whether there are any of these molecules related to life. There are certain molecules like the amino acids which may be described as the building blocks of life. The meteorites present to us the only prebiotic matter we have laid hands on. So we like to find out whether in this meteorite, in these samples, are any amino acids, any hydrocarbons. So the process is one of extracting the meteorite, taking the molecules that are in there, dissolving them in a solvent that will get them out. Then we have a small amount of liquid that will contain some of these molecules. At that point, we will go to a gas chromatograph, an instrument that will separate these components. We will inject a very tiny sample into a gas chromatograph and see whether these individual components can be picked up by a detector.
Dr. Panemparuma has found organic compounds in the meteorites, organic compounds which are necessary for all life, and they are different from any found in living organisms on Earth.
What does that imply is that all those events that led to life may be common in the universe. So what we said happened on the Earth may be happening somewhere else.
Another member of the solar system family is the comet. A comet looks like a light bulb with a tail, yet comets give off little of their own light. Their dust reflects sunlight, thus we can see them. Like planets, comets orbit the sun. According to one theory, the nucleus of the average comet is like a dirty iceberg. The nucleus is made of water, methane, ammonia, carbon dioxide, as well as other materials. Embedded in this ice are chunks of rock and metal. Photographs show that the ice ball nucleus is surrounded by a cloud of gas and dust. The cloud is called the coma. There is also the tail, which always points away from the sun. The tail becomes evident when the comet nears the sun. Scientists have analyzed comet dust, and they think the dust may be 4.5 billion years old. Perhaps comets contain the original stuff from which the solar system was formed. Some estimates are that there could be 100 billion comets. Most of them are theorized to be at least 9.3 trillion miles from the sun in a sphere called the Oort cloud. Sounding rockets, satellites, and observations made aboard the orbiting Skylab have confirmed the identities of many of the materials in comets. But comets are difficult to study from long range, because many scientists think comets could hold some of the answers to how the solar system was formed. There have been plans to use spacecraft to closely study comets. Now we will see a film clip called Comets, Windows into Time.
Comets, lonely wanderers of the night sky, drawn to the sun as a moth to a flame. Comets were born with the sun and the planets 4.5 billion years ago. But unlike the planets, the primitive ices and dust of comets have remained unchanged. They are windows into time, back to our beginning. Comets are woven into our history and our legends. For centuries, they were feared as evil omens, harbingers of ill fortune. Apprehension and superstition greeted their arrival. But even as some feared these mysterious streaks in the night sky, others, not affected by superstition, saw them as part of the natural world that they wanted to understand. Among them was the English astronomer Edmund Halley. He not only tracked the great comet of 1682 and calculated its course, But he was also perceptive enough to realize that this comet had been observed many times in the past. He predicted that it would return every 76 years, again and again. Halley was ridiculed for his prediction, but the comet's next return proved that he was right. When this comet, Halley's Comet, returned in 1910, millions of people were fascinated by its appearance. This greatest of all comets was intensively studied by scientists and photographed for the first time. Our present knowledge about comets is limited to what we have observed from Earth. We believe that at the heart of a comet is its nucleus, an irregularly shaped ball of ice and dust. Surrounding the nucleus is the coma, a cloud of gas and dust that is boiled off the comet by the sun. Our knowledge stops at the visible coma. The coma extends into the tail, the most striking feature of a comet. The tail develops slowly as the sun's energy reaches out to the approaching comet and stretches the tail across the sky, sometimes for more than 10 million miles. Many new comets continue to enter the solar system, even as old ones disappear. But from where? If we were to travel away from the sun, leaving the planets behind until they fade into the blackness of space, and until the sun itself is just another bright spot in the sky, we would see a thin cloud of objects enveloping the entire solar system. These are the primordial comets, billions of icy globes no more than 30 miles across. They have been here unchanged since the beginning of the solar system. Halley's Comet began its first journey around the sun thousands of years ago. It will come near Earth again in 1986.
In 1972, Dr. Fred L. Whipple suggested that Uranus and Neptune are big comets. His theory is that billions of small cometesimals make up those planets. Whipple, by the way, is the astronomer who in the early 1950s proposed a model of the average comet which seems to fit observations of comets. But we cannot see Uranus and its 5 known moons very clearly from earthbound telescopes because of the great distance to them. Uranus is about 19 times farther from the sun than is Earth. In this view, we see arrows pointing to 3 of the 5 known moons of Uranus. Uranus is smaller than Jupiter and Saturn and is 14 times more massive than Earth. The NASA Flying Kuiper Observatory was used to discover rings of Uranus. Below its 9 known rings, Uranus is believed to have a deep atmosphere made mostly of hydrogen and helium. Methane is present, giving the planet its greenish color. Scientists believe Uranus has a core of rock and metal surrounded by ice layers. To help give us a better picture of Uranus, the Voyager 2 spacecraft is set to encounter the blue-green planet in 1986. Judging from the excellent views we received of Jupiter and Saturn, NASA will make any new discoveries about a planet ground-based observers have never before seen at close range. Scientists predict discovery of more Uranus moons. According to Dr. Dale Cruikshank of the University of Hawaii, The 4 moons of Uranus that we are able to look at are made of water, ice, and dust. Cruikshank says astronomers are able to measure the heat of radiation of the moons. Those temperatures are colder than that of liquid nitrogen. The 8th planet from the Sun is Neptune, and it is very much like Uranus. Neptune is the smallest of the gas giant planets. Neptune is bluish, probably due to a variable haze layer in its atmosphere. Neptune has 2 known moons, one of which is shown here by an arrow. A 3rd known moon may have been discovered in 1981, but its presence must be confirmed. The largest of the 2 moons is Triton, and it is about in the same range as our moon. According to Dr. Cruikshank, Triton is covered with patches of methane ice, distributed non-uniformly on the surface. The atmosphere, he says, has to be at least a thin methane atmosphere. Some scientists predict that Triton has locked rotation. That is, one face of Triton always faces Neptune. Cruikshank wants to find out which face of the moon Triton, the face towards or away from Neptune, has more methane. Concentrated observations of the large Neptune moon scheduled for May of 1983 may provide Cruikshank with the answers. In 1979, pictures taken through the 60-inch Catalina Observatory telescope with a charge couple device revealed different regions of Neptune. High clouds of crystals in the northern and southern hemispheres produced 2 bright areas. At the time the pictures were taken, the absence of a haze layer in the Neptune region allowed us to see a deeper layer of methane gas. The brighter features of the equatorial zone were seen to move eastward around the planet. Neptune, which is about the same size as Uranus, is about 30 times farther from the Sun than is Earth. In 1989, the Voyager 2 will have its closest encounter with Neptune. Perhaps then we will confirm some of our predictions about the planet, as well as answer some questions. Will we find rings around Neptune? What will clearer views of the upper atmosphere of Neptune reveal? Neptune takes almost 165 Earth years to orbit the Sun, nearly twice the time it takes Uranus to circle our home star. Neptune radiates more heat than it receives from the Sun. Uranus does not. This suggests that the core of Neptune is molten rock and iron with a temperature of about 12,600 degrees Fahrenheit. Neptune is traditionally known as the 8th planet from the Sun, yet since 1979, Neptune has been the most distant planet. This is because Pluto has a highly elliptical orbit. Pluto will be within the orbit of Neptune until 1999, when Pluto will once again be the outermost known planet. Only 17 Earth years of Pluto's 248-year orbit are spent inside the orbit of Neptune. At present, there are no plans to send a probe to Pluto. Of the 9 planets, it will be the only one not visited in this century by an automated spacecraft. Pluto was discovered in 1930 by photographic means after a long search for the 9th planet. The search began after astronomers discovered that the orbital motions of Neptune seemed to be affected by a large mass beyond it. Yet the mass of Pluto is small. In the 1960s, high-speed computers were used to analyze orbits of the outer planets in relation to estimates of the mass of Pluto. Those estimates of Pluto's mass fell from roughly a 1/5 of the mass to a 1/10 of the mass of Earth. Then in 1978, U.S. naval astronomer James Christie declared that he had discovered a moon closely orbiting Pluto. The moon was named Charon, and it was estimated to be as much as a quarter of Pluto's mass. Based on observations of the new moon, estimates of Pluto's mass went down to 1/500th that of Earth. The mass of Pluto is important because if it is as small as calculated, something else must affect the orbits of Uranus and Neptune. One theory is that a 10th planet exists somewhere beyond Pluto's orbit. Some astronomers speculate a dark star, as many as 50 billion miles from Pluto, could affect the outer planet orbits. Another possibility is that a black hole could be 100 billion miles past Neptune's orbit, and the black hole could affect the orbits of the outer planets. A black hole is believed to be the final stage of a collapsed massive star. The material of the collapsed star is so densely packed and the force of its gravity is so great that even light cannot escape its pull. The Pioneer spacecraft, which first surveyed Jupiter and Saturn at close range, are now the two man-made objects most distant from Earth. By July 1983, Pioneer 10 will be beyond the 9 known planets. Pioneer 11 is nearly as far out as Pioneer 10, but at the other side of the solar system. Scientists think that the two Pioneer spacecraft will be able to help predict the distance and size of an object which could affect the orbits of the outer planets. It is thought that a massive body, which is a relatively long distance from the outer planets, would exert about the same gravity force on both Pioneer probes, even though they are at opposite sides of the solar system. On the other hand, a smaller body, closer to the outer planets, might only affect one of the Pioneer spacecraft. Man is just beginning to study the boundaries of the solar system. To delve into the unknown, man must use spacecraft. In the next few years, if the Voyager 2 spacecraft missions to Uranus and Neptune go well, some of the theories presented here will be replaced with fact and new questions. Meanwhile, the Pioneer 10 and 11 spacecraft continue to sail the cosmos into what could be eternity in human terms. Each of these probes carry with it a message to other possible residents of the universe. The message is designed to show intelligent beings elsewhere the origin of the spacecraft. The communication is etched into a gold anodized aluminum plate 6 by 9 inches, and it is attached to antenna support struts. The lines radiating from a common point show our sun's position relative to the 14 pulsars. The 1- symbols are binary numbers showing the frequencies of the pulsars relative to the hydrogen atom. A symbol of the hydrogen atom is in the upper left-hand corner. Near the bottom of the message, the solar system is represented, and Earth, the third planet, is seen as the origin of the Pioneer probe. Perhaps never, or perhaps millions of years from now, intelligent beings will rendezvous with Pioneer in space and decipher its message. Will they be able to appreciate or comprehend the outlines of the beings, man and woman, etched into the plate? The two Voyager craft carry with them even more sophisticated messages for extraterrestrials who might intercept the craft millions of years in the future in some remote part of the Milky Way. Encoded on a disc, much like a phonograph record, are sights and sounds selected from around the world. This ends our series of 13 programs called Journey Through the Solar System. Now let's see some of the sights and sounds of our world being sent to the far reaches of space.
We step out of our solar system into the universe seeking only peace and friendship, to teach if we are called upon, to be taught if we are fortunate.
Our fantastic journey is not at an end. Mankind will continue to explore and learn. We have just begun.
Hello from the children of planet Earth.